Hey guys, today we look at some Verilog features. First, we will look at ternary operator, then we will look at reduction, and finally, we will look at generate for loop. So let's start with the first problem. In this problem, we have 4 inputs, A, B, C, D, and our task is to find the minimum of all of them. So find the input that has the minimum value. We will use the ternary operator to do this, and it has this structure. So we have question mark. Here there is some statement. It will be either false or true. And if it's true, then we choose this one. If it's false, then we choose this one. So we will create TMP1 and TMP2, and they will choose if A is less than B, then we choose A, else we choose B. And this one will choose C is less than D. And if it's C is less, then we select C, and otherwise we select D. So in our TMP1, we have the minimum of these two. In our TMP2, we have the minimum of these two. And now we will assign the final minimum. And that will be TMP1 is less than TMP2. And in that case, we select TMP1, else we select TMP2. And we will get the minimum of all of these 4 inputs. And we got some error, and this is because I forgot to create the TMP wires, so they will be 7 down to 0, and it's going to be TMP1 and TMP2. Okay. Next, we will look at reduction. So if you want to create, for example, AND gate, and you want it to operate on all of the bits of the vector, like you can see here, then you have to do it. It's quite tedious. You have to do it like this: A0 and A1 and A2 and so on. And we can use reduction operators to do this. So reduction operators look like this, and it's the equivalent of writing this whole code. So we can look at our problem that we have already done for input gates. So in this case, we have done it like this. We have to write in 3 and in 2 and so on, but we can write it just like this. So in this exercise, we have to create even parity check, and we can do this by XORing all of the 8 bits. So this can be done really simple. We can just write assign parity, and this will be equal to and between all of the in bits. So this is the reduction operator. Next problem is very similar. We will also use reduction operators, and this time we have to do out AND, out OR, and out XOR. So it's gonna be very simple. We will just do assign, then out AND, and this is gonna be AND between all of the input bits. Then we do assign out OR, and this is gonna be OR between all of the input bits, and finally assign out XOR, and that's gonna be XOR between all of the input bits. Very simple. Next problem, we are given a 100-bit input vector, and we are supposed to reverse its bit ordering. So for this, we will create a for loop. I will first create always combination always block. So it's gonna be combination, so asterisk here, begin, end, and here we will create a for loop, and this is just very simple for loop. So int I equals to 0. If I is less than, here we can use this function, and this function returns the length of the vector. So in this case, this is gonna be 100 because the input vector has 100 bits, and then we say I++, which will increment, and here we have to reverse the ordering. So we say out equals to, and out I will be equal to in, and here we can use this again, -1 minus I. like this. So this will reverse the ordering of the vector. This problem is called population count, and we have input that has 255 bits, and we have to calculate how many of the bits are equal to 1. And we will also use for loop for this. So I will create always combination always block. Begin. And here I will assign out to 0, and then I will create a for loop. I will be less than the number of bits in the input, I++. And here we can just assign out plus equals, or out equals out plus, and in I. So what this will do is, if in is equal to 1, it will add 1 to the out, and if it's 0, then out will stay the same. So out will be equal to out plus 1 plus 0. So this is gonna count how many bits are equal to 1. And we have some error. So here I forgot semicolon. Finally, we will look at generators. And in this exercise, we want to add 100-bit A and B together using 100 full adders. So we will create 100 instances of full adders and connect them, and this will give us the sum. We have already created full adders here. This circuit here is full adder, and this is module f_add that we have created in the previous episodes. So I will just copy this module. So this module will give us the full adder, and I will copy it here. And here we have to create 100 instances of this module. So first we will create the first bit add. So add 1, that will be add instance 0. And this instance will take A0 as input, B0 as the second input, then carry in, and it will output sum 0, and we also have to create, or in this case we don't have to, we can just assign this to count 0. And here we will generate another 99 instances. First we create genvar I, and this tells Verilog that this is just temporary variable that will not be used in the final design. Then we say generate and generate, and here we can generate some code. So it's the same as copying this 100 times. And we will create a for loop. We will use our I, assign it to 0. Then we say I is less than, and we will count the bits in our sum, I++, and begin. And we have to name this for loop, so full adders, end. And here we will generate 99 copies of this. And we will start from 1 because our 0 is already initiated here. And this is gonna be instance I. So here we will just put I for A and B. The carry in will be the carry in from the previous one. So that means we will take carry out I-1, which will give us the carry out from the previous one. Sum will also be I, and carry out will be assigned to I as well. Okay. Final problem is very similar to the previous one, but this time we have to add BCD numbers, and we are given this module BCD that will add the BCD numbers. So it's very similar to the previous one, so I will copy the code from here, but our sum and count, they are swapped here. So count is first, then sum. So we have to swap these two. And here too. This is gonna be called BCD adders. And we will initiate these instances. And also the BCD number is 4-bit. So here we have to say 3 down to 0. So we will take the first 4 bits of A and first 4 bits of B. That's the first BCD number. And here we will have to create a var. That will be 100 bits, so 99 to 0. It's gonna be calledtout tmp. So carry out temporary. And I will copy this here. This is gonna be 0. And sum is gonna be 3 down to 0 as well. So we get our carry in. We calculate the sum of these two BCD numbers. We will output it here. And the carry out will be saved to this temporary vector. And here we have to generate the another instances. And so this is gonna be, so first I has a value of 1, and we need this number to be 4 and this to be 7. So I times 4 will give us the 4, and I times 4 plus 3 will give us the 7, and then it will count all the way to 100. So we don't want to count this. We want 100 here, or we can do it divided by, or I think 100 is better in this case. We will copy this here and here. Wait, only here. And our carry out will be taken from the previous one, and our carry in will be carry in will be from the previous one, and carry out will be saved to the current one. So this seems fine. Let's go through the code. So this is the first one. That seems correct. Then we create another one. We create 99 copies of them. And here, this is gonna be I times 4 plus 3 to I times 4. So that's also seems correct. That's here as well. And here I minus 1 and I. And also we have to assign our carry out at the end. So assign carry out will be the last of the temporary vector, so 99. Okay. And we got an error here, and that's because here I forgot to rename this to the temporary one. So now it should work. And the last problem is finished successfully. We have finished Verilog features. So that's all for this Verilog language part. So next time we will look at circuits, combinational logic, and we will start with basic gates. Then we will look at multiplexers and so on. So if you want to see the next video, don't forget to subscribe. I'll see you in the next one. Bye.